We're talking about MSDS this year. Is there anything that caught your guys' attention? Anything that caught your guys' attention? Something. Yes? Yeah, what about this? Absorb so quickly it may be fatal in 90 seconds? Like, I don't know what phenol is, but I don't think I want any of that noise. Anything else that sort of stands out? You're like, that's concerning. Give me something. Emerson, give me something. Anything.
Your skin will severely blister.
Yeah, severe blistering? What do you mean severe blistering? Why would that happen? Huh? What about highly toxic by ingestion? Like, wait, what is all that? It smells like disinfectant. That's, okay, I guess that's interesting. Carbolic acid? Okay, that's cool, I guess. Call a physician, seek medical attention. Let's see here. If breathing has stopped, like, what do you mean if breathing, like, why would breathing stop? Okay, this is an MSDS, stands for Material Safety Data Sheet. They sometimes just call them SDSs now for safety data sheets. This is the doomsday scenario for phenol. So it comes up with anything like the worst possible cases for whatever chemical it is. You need to know what to do. So for example, by law, I have to have an MSDS for every single chemical we use in class, even if they're pretty, tame. Because I just need to know what to do in any circumstance if anything goes down, like worst case scenario. Because right here in front of me, I do have cough syrup. One of the main ingredients, phenol. Right here. And you're apparently supposed to drink this sometimes if you have a sore throat. Or the sprays have phenol in them lots of times. What the heck, Mr. P? So like I said, this is all about the doomsday. This is the worst case scenario. Is that a question over there? Just do a little paw yoga, I see. And it's also, this is usually for like 100% pure phenol, whereas this is just a fraction of a percent over here, my little cough syrup guy. So MSDS just give you the worst case scenario. You can Google any of them if you ever want. So I have here a can of pop Mountain Dew. One of the main ingredients, citric acid. If you Google citric acid MSDS, you're going to see some shocking things. You're like, oh wow, that sounds serious. So in MSDS, it just gives you the worst case scenario for the pure form or the most pure form of that substance. But here's the thing that you really got to know. I'm going to say this so many times you're going to get very annoyed with me. Flip over. Section 9. Section 9. Section 9. Section 9. Section 9. Oh man, I just feel like some real Section 9 today. Dude, did you see the Section 9 on that Section 9? What is Section 9? Am I right? Section 9. Harry, if you section a 9 one more time in this class, I will Section 9 you so fast it'll make your Section 9 spin. Okay? Section 9, Section 9, Section 9. Oh, Ryan, so I'm thinking of a section. It's not quite 8. It's not quite 10. It's what is it? It's oh my gosh. Set what? 9 what? Section 9! Section 9, Section 9. Never forget Section 9, Section 9, Section 9. Okay? I hope that is now Section 9. I hope that's burned into your brain. Okay? Never forget. Section 9 on MSDS is super helpful because it gives you the basic chemical and physical properties, which are what you're going to need to know when you get to something. It tells you what it should look like. It tells you general stuff like, oh, it's soluble in water, or it's insoluble in water, or it'll tell you like density lots of times, or it'll tell you the boiling point. So if you're trying to figure out how to separate something, let's say, okay, Section 9 can be your best friend. Okay, and it gives you the general information. So Section 9, never forget, Section 9 is what we're looking for when we get to an MSDS. Okay? So in the future, if you were to get one, that might be the first place I turn. Does that make sense? Understanding? Okay, great. Now let's go ahead and bust out these notes. They're not going to take super long. It's 10:29 right now. I think by about 10:49, we'll probably be done with the notes, right around that time period. Let's go about 20 minutes of notes. Now this first page right here, you may write down some of this, you may not. This is just what I was saying. But basically, MSDS, information on chemicals. Always look at, oh man, Danielle, I just cannot remember. You always are supposed to look at, huh? Section 9. Thank you, Danielle. Section 9. Whereas physical and chemical properties. That's right. Section 9. Okay. Now, anyways, I'm going to go ahead and move past this. You don't need to write that down. Let's talk about a candle, okay? This is the mass from last period, so you don't need to write that down. I have a candle here. I'm going to get the mass. I do want you to write that mass down. I got 0. The mass of this candle is 79.42. I want you to write that down, please. 79.42 grams. So I'm going to go ahead and light this candle here. It will remain lit the entire time we're taking notes. Wait, the notes are going to be lit and the candle's going to be lit at the same time? You guys see, because it's going to be really enjoyable. So I just want you to kind of predict. You just draw an arrow. What do you think is going to happen to the mass of that candle? If you think it's going to go up, just give it one of those. Down. If you think it's going to stay the same, you can just do one of these guys. Just put a little arrow, a little prediction. We'll come back to this. Yes, ma'am.
Okay, well, you're keeping it on the scale, right?
The whole time. I'm not going to touch it.
That little thing under it, which means that all of the stuff that comes down is going to go into the trend.
Right. Yep. Yeah, all the wax, if it drips, not just because I don't want to make a mess, but it should just land in that little, that's why I have that on there. Yep. So it's on a weighing boat for you guys at home. So anything that drips off the candle, it'll land in a weighing boat, so it'll still be on the balance. Yep. All right. We'll come back to this. Just make sure you have that number written down. Now let's talk about the difference between a liquid and a solution. You guys have probably been using these words interchangeably, which was okay until this moment right now, but you need to make sure you know the difference. A liquid represented by a little L in parentheses, like the L I took in my quick. No. Just a little L, okay, for liquid. Liquids are actually pure substances. So if you ever have a liquid, it has to be either an element or what's the other option for a pure substance? A compound, that's right. Okay. So it's going to be one of those two. Some examples. H2O, when I say H2O, I mean like distilled, pure H2O. I'm not talking about the stuff out of the faucet. Okay? H2O, ethanol, mercury, something like that. Liquids are actually rather rare. We don't use them much, if at all, the whole school year. But a liquid, when we put an L, we're talking about something that is pure. Okay? So when you pull a little molecule out of that beaker, you're getting nothing but H2O. It's like you're never going to accidentally grab a fluoride or something like that. Now, a solution, that is a homogeneous mixture. Okay? A mixture of dissolved ions. So you got more than one thing in there. So when we say solution, we're not talking about pure distilled water, for example, which is a pure substance. We're talking about more than one thing. Okay? So you grab something out of that beaker, there's a chance that you could get a different thing from two different pools. Now, I will say that 99.99% of the time, a solution isn't just a solution, it is specifically an aqueous solution. And aqueous referring to the idea that it's water-based. So a little AQ, you definitely want to put that little AQ in parentheses. You are going to see that a lot. You're going to see that a whole bunch. You're going to see that a whole bunch. So stuff like Kool-Aid, salt water. You kind of look over in this direction, sort of behind these stations over here on the right side of the room, or my right, your left. All those bottles up there, you see those in those cabinets. We use those for labs all the time. Every single one of those, like literally every single one of them, is an aqueous solution. So we have something dissolved in water. So it's mostly water, but it has something else dissolved in there. Makes it really helpful for reacting quickly. But yeah, aqueous solutions, AQ, you're going to see that a whole bunch, so get used to that. Get used to that for sure. And by the way, gases and solids also have their own designation. So gases with a little g, solids with a little s. So they'll have their own designation. So if you ever see a chemical name and it has like a little g after it, it means it's in gas form. That's what that means. That's what that means. So we got the little L for liquid, AQ for aqueous, G for gas, S for solid. It's supposed to be fairly straightforward. Yep. Alrighty. So now you guys are we're going to discuss briefly about precipitate. So a lot of this I hope should be some review. Precipitates are solids formed out of a solution. Okay? So you have a solution or two, and all of a sudden a solid forms out of it. It's falling out of the solution. Why does it do that? Because it means it's insoluble. Okay? The reason why the precipitate, so if you remember yesterday I poured two solutions together, you got this white solid. The reason why that white solid even appears is because it's insoluble. If it was soluble, it would just look like a clear solution, so it would look like nothing happened. Okay? That's why precipitate forms, is because it's insoluble. If you look at my super dorky shirt right now, if you're not part of the solution, you're part of the precipitate. Do you guys get it? Like when people are like, if you're not part of the solution, you're part of the problem. You're part of the precipitate because it's an insoluble solid that formed. Do you guys get it? Okay, a little more laughter. Laugh right now. Ha 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 ha. There you go. Helps your grade. Watching you, Harry. Anyways, how can I separate precipitate out of a solution? Hey, what are the methods you could use to get precipitate out of there? Filtration, love it. There's another one that you can use. The centrifuge, right, where you spin around and the dense insoluble solid gets stuck at the bottom. Yep. This guy will do it. That guy will do it. Great methods for separating precipitate out of a solution. Because it's insoluble, because precipitates are insoluble, that's why you can use those. If the precipitate wasn't soluble, first of all, you wouldn't be able to see it, but second of all, you wouldn't be able to filter it, because it would go right through that filter. Remember, the food coloring in the water went right through it, okay? And when we centrifuged the food coloring and water yesterday, it didn't do anything, because food coloring, again, is soluble. So, is the creation of a precipitate, is that a chemical or physical change, by the way? What would evidence suggest? Chemical or physical? Physical. Why? Well, it's not dissolved, right? Because that's why it fell out of solution. What do you guys think? Chemical or physical? I'm going to ask why. I know what you say. Is the creation of a precipitate, so when a precipitate forms, is that chemical or physical? What is that? Is that chemical or physical change? Chemical. Physical. Which one is it?
Separating it.
Not when you separate, it's just when you pour them together and that solid first forms.
Oh, yes,
Also chemical.
It's definitely chemical, right? The two things I would probably point to make my case, if I was arguing this, I'd say you have a new solid formed, right? And the color change. Remember, when I poured them together yesterday, you got that bright white color. Color change doesn't literally always mean that there's a chemical change, but it usually does. So that's the thing I point to, like, okay, it's probably chemical because that color change happened. Probably was. And by the way, this stuff right here, I don't want to spend much time on this because this should be reviewed. We mentioned this a couple times. But remember, solubility, the ability to dissolve. If you can dissolve, that's soluble. If you can't dissolve, that's insoluble. Salt is soluble in water. Baby oil is insoluble in water. Okay? So just make sure you remember those terms. Never forget. Precipitates, are they soluble or not? Precipitates, are they soluble? No, that's why they form in the first place. Okay? That's why they form, is because they're insoluble. If they were soluble, it would look like nothing happened. Look like nothing happened. All right. All right. Got that out of my system. Cool. Boom. Boom. Let's go ahead and write this equation for me. Magnesium sulfate plus sodium hydroxide. And then draw a big arrow to the right of them and leave some space. Okay? So you're going to write the words magnesium sulfate plus sodium hydroxide. For those of you at home, these will be on your notes already. You have a big arrow there. I wouldn't expect you to know this, but when you mix those two things together, which I'll be doing for you here in a moment, the magnesium and sodium basically switch places. So instead of magnesium sulfate, we have magnesium hydroxide. I don't know why that appeared. And instead of sodium hydroxide, we have sodium sulfate. So we're going to go through all the different parts of this. This is called a chemical equation. This is called a chemical equation. And I do have these two chemicals up here. So notice what they both look like. Here's one. And here's the other. They both have that clear solution look. So what that means is that they're water-based. They're both aqueous. So you want to put a little AQ next to magnesium sulfate and sodium hydroxide because they are aqueous. They're water-based solutions. All the stuff before the big arrow, no matter how many things it is, in this case it's only two, but all the stuff before that big arrow, those are called reactants because they're the ones doing the reacting. They're the ones doing the reacting. There will come a day on your test where I'm like, hey, which ones are the reactants again? And you need to be able to tell me anything before that arrow, before the big arrow I have highlighted there. It could be 10 things for all we know. Again, in this case, it's only two, but now this big arrow, it's called a yield sign. That's what the big arrow is called. It's called a yield sign. And you can think of it as an equal sign, or you can think of it as the words to produce. So to start this off, aqueous magnesium sulfate reacts with aqueous sodium hydroxide to produce. Now magnesium hydroxide, you guys saw this yesterday. It was a chunky white solid. So what am I going to have in parentheses right here? Yep, little S for solid. And for the sodium sulfate, it's still just dissolved in the water, so it's just going to have a little AQ. AQ is by far the most common designation. You'll see AQs all the time. You'll see AQs all the time. And everything after the arrow, again, in this case it's only two things, but it could be a million things. But anything after the arrow by definition is called a product. Products are produced. Reactants are the ones doing the reacting. So let me read this for you. Aqueous magnesium sulfate reacts with aqueous sodium hydroxide to produce solid magnesium hydroxide and aqueous sodium sulfate. That's what that is. That's what that is. Again, precipitate, formation of a solid in solution. Or precipitate soluble, all that good stuff. All right. So, here's what's going to happen. I'm actually going to mix those two things together. This is our old number from last period. Right now, the mass of these two things, I have them on a little beam balance here. You guys might recognize these from the doctor's office sometimes. Let's see. I have a total mass of, I'm kind of measuring this out here. Looks like we got, you're going to write this down, 108.37. We got about 108.37 grams of stuff. Grams of stuff. I'm going to pour these two together. I'm going to mix them, okay? So let's see what happens to the mass. So I pour them together. We get that white precipitate right there, insoluble solid. Oh, it looks like the mass went down. Looks like the mass went down. Did it? I gotta put the beaker back on, right? As a matter of fact, the mass stayed exactly the same. It's still 108. Even though a chemical reaction definitely just went down, we have a color change, we have a new solid form. Okay? Even though the chemical reaction just happened, the mass did not change. And here's the big idea. Absolutely, positively need to know this. Burn it into your brain. The law of conservation of mass. It's in bold. It's in red. It's highlighted. It's all capital letters. The law of conservation of mass. Or sometimes law of conservation of matter is what some people call it. Here's the idea. Matter cannot be created or destroyed. It is literally impossible to create or destroy mass or matter. It can't be done. It is impossible. It is impossible to do. Sometimes in a test situation, to give an abbreviated version of this, I'll see Billy throw matter before equals mass after. People will throw that my way. It's like, look, the matter before has to equal the mass after. That just has to be true. Nature demands that to be true. Nature demands that be true. And that's why the mass before and after this, even though a chemical reaction definitely happened, it's exactly the same. Now, I will say matter, it can move or it can change phase. You can have a gas become a solid or something like that. It can move around. So like I take this, the mass on this table is a certain number, but if I put the stopper and put it on another table, it's not like I've created or destroyed mass. Yeah, the mass isn't here anymore. It's over there. But I haven't created or destroyed anything. All right. I'll never ask you for the definition of the law of conservation of mass. That's a very boring question. But I will ask, you'll probably need to know it to explain yourself or argue your case in a quiz or test situation. Let's go back to the candle from the very beginning. What was the mass you guys had? 70. Thank you. Okay, so the mass of the candle should obviously be 79.42, right, according to the law of conservation of mass. And it is, in fact, 78.28. It just went down. What? It's still going down. It's now 78.28. Mr. Pilger, you literally just lied to us. Wait, how's it? What the heck? How come the mass went down? That's not possible. You just said the law of conservation of mass. It must be somewhere else, right? I love that thing. You're like, well, it can't be destroyed, so it has to be somewhere else. What's your best guess? Where do you think it probably is? It's somewhere in the air. I love that. So the mass wasn't destroyed. So if you go into this is a great thinker question on the test. You think to yourself, okay, well, I know the mass can't be destroyed. That's not possible. So I love how Sage was kind of breaking out. She's like, well, it has to be somewhere else then. Like, it can't have just gone nowhere. And then people kind of feel like, oh, it must be in the air or something. I don't know. It's best guess. I wouldn't necessarily expect you to know for sure it's in the air. But if you can explain to me, well, I don't know where it is, but it's got to be somewhere else. Okay, it didn't disappear. Can't be destroyed. Yep, the mass of the candle actually went to the air. And here's the part that's sweet about candles. So literal candle wax is going into the air. Like, that's actually what's happening. Candle wax is actually going into the air. So when you blow these out and the smoke is on there, hey, look at that. I told you this would be over just about now. You should be able to relight a candle by just the smoke, because the smoke itself should actually contain a little bit of candle wax. Every time you smell a nice candle, that's because a piece of candle wax literally went into your nose. That's how you smell it. So let me go ahead. You guys will get to try this, by the way. I'm going to put this out here. I should be able to. Nice, I finally got the candle relit. Awesome. Now you guys go ahead and go do it on your own. Let's have some fun. Lines to the right.